Hey, welcome back to the channel. My name's Big John, and what we're going to start talking about a little bit today, we're going to introduce land navigation. Uh, some of my thoughts on it, the classical way of doing it, and hopefully a little easier way of doing it as well. Uh, this will be an introduction to foot patrols. Uh, Again, a disclaimer: I'm not prior military. I've never served a day in my life. Uh, I have backpacked a good bit, uh, and I've taken some classes. So the navigation side of it, I feel pretty confident about. Plus, I worked in forestry for almost 20 years. And as they asked Daniel Boone one time, they said, "Have you ever been lost?" He said, "No," I said, "I ain't never been lost." He said, "I was fierce and confused for a couple of months, but I ain't never been lost." Well, I have been lost. And if you do it long enough, you'll get lost too. But what we're going to do, and I'm not sure how well this is going to work. This is kind of an experiment. Uh, the camera work's not going to be the best in the world. For the simple fact is, some of this is going to be hard to see, so I'll be zooming in. But the important stuff on here, I'll take the map off, if not in this video, in another following video, and I'll just hand draw some of this stuff. But what I want to introduce you to, this is a USGS quadrangle map. A map has a few things to be considered a map. It has to have a north arrow. It has to have a scale. This one does. Now, this is a 1 to 24,000. So what that means is 1 inch measured on this map is 24,000 inches in real life. Or 1 mile or 1 kilometer would be 24,000 kilometers. Or, of course, I mean, you couldn't get that on the map. But this is what I grew up on, was a quadrangle. For what we would probably be doing if this was, for lack of a better term, a survival situation, probably a 1 to 50,000, maybe even a 1 to 100,000 might be just as beneficial. And I'm going to explain my reasoning behind that. The larger the scale, the less detail. The problem you get into is all this isn't as it seems, okay? They started doing these in the 50s. And so what they do, they'd take them off aerial photographs. Well, they were doing them earlier than that. I mean, of course, we had land surveyors, Lord, I don't know when, I guess Middle Ages. I mean, the chain is 66 feet, and that was established, I don't know how many years ago, But with the quadrangles, they started more in the 50s, and they started using aerial photography. Oh, the technical term is aerial photogrammetry, but aerial photography. And then they would base the maps on the aerial photographs. The problem is, especially in rural areas, is we have a thing called tree cover or canopy. And it's hard to tell sometimes what's under that canopy. So as we go over the parts of the map, one of the things we're going to look at, and I will zoom in when I go over the parts of the map, is what's called contour lines. And once you get used to it, you can actually do in your mind a three-dimensional image of this 2 dimensions. You'll actually be able to see it in 3 dimensions. You'll see saddles, you'll see spurs, you'll see valleys, hills. What hill is taller than another hill? You'll actually, after a little bit of practice, be able to do line of sight. Would I be able to see point C from point A if I'm looking through point B, or is point B going to block my line of sight? That will become more important when we start discussing communications. The problem is they used a little bit of artistic license when they did this. So everything you see on here, don't expect it to be actual ground truth. Now it's going to be close, especially the larger terrain features, and especially man-made terrain features. For instance, this road right here, this is County Road 12. This is US 171, just above the county line. And this is Concord Baptist Church. I know I'm giving away operation. This, op spec is went out the window because I've shown you a map, But uh, intersections, very good. That's a good place to get set up for rally points or RVs. It's also a good place for you to figure out where you are, because these are going to be mapped very well. Now, for instance, this right here is, all right, this is the Sipsey River. And I know this is, we call it the Sipsey Swamp, but it's actually a river bottom. And this is low ground right here. And I'll zoom in a second, but it's a darker green and has little tufts of grass. And that signifies that this is lower elevation or further below sea level than this area is right here. Now, is this going to be 100%? No. It's going to be a good approximation. But your buildings, like I say, I got off the map there. And this is magnetic. It's going to mess me up. Right here, this intersection, that would be something that would be easy to see on the ground and match the map. All right, this is a man-made lake right here. That will be easy to spot. Let's see what else we've got here. Well, that gives you some idea. So, so what we've got, this is your scale. This is going to tell you what the scale of the map is. So like I say, it's 1 to 24 thousandths. It will also tell you your contour interval. And again, I'm going to zoom in on this. Plus, this is some stuff I will draw. And it'll be hand drawn, but it'll be larger and it'll be easier to see. But if you look at all these reddish brown lines right here, these are contour lines. And if you will look, and this is going to be difficult for y'all to see as well. Let's see here. Let me find one. And I'm probably going to pull my glasses off to even see it, to get the number. Okay. This point right here is 405 feet above sea level. Now, if I come down one contour line, then I would be 385 feet below sea level, 365, 345 on down. And of course, it goes the other direction. Don't get too bent out of shape or wrap your mind around too much of the elevations. You'd have to have an altimeter for them to really help you. And those are based on barometric pressure. And so if your barometric pressure changes, they lose accuracy. But it gives you an approximation. Is this hill taller than this hill? That sort of thing. Main thing you're going to use your contour lines for is the shape of features, topographic features. How steep are they? For instance, this area right here, if you look, your contour lines are closer together than right here. So this is a more gentle slope than this is. And if you look, there's a little blue line, dashed line coming through here, and that's a creek or a branch. So what you've got a ridge coming down here. You've got little spurs sticking out. And on this side, you've got kind of a ridge, and the creek runs down the valley in between. Water runs downhill. Now, if you're wondering, is that a ridge or is that a valley? Well, if it's water, chances are it's a valley. Most time, you creeks don't run on top of a ridge. Just common sense. So, but right here, you see these contour lines are wider apart than these contour lines. So this will be a more gentle slope. You're still going uphill from the creek up to the top of the ridge. And I know in Alabama, in this part of Alabama, ridges are somewhat of a euphemism, because compared to the Smokies or the Rockies, they would consider these ridges at all. But this side would be a lot harder walking than this side, because this would be a more gentle slope than this side. Now up here, it's even steeper. And now this is the top of the hill. Because if you'll look, and I'm going to use the end that's not magnetic, you've got a circle right here. That's showing that's the top of that hill. And it's actually named. Now, you've got another spot, another top of the hill. Now look how much closer these contour lines are together than these ridge lines. So you come off this hill, you got, this is a ridge coming in. So you go down into a little saddle, come up, down in a little saddle, come up, down into a little saddle. You're going to come up, moderate slope to the top, go down a moderate slope, and then you're going to go up a pretty steep incline right here to get to the top of this hill. Then you're going to come off a steep incline to get down to the Sipsey River, get down into the bottoms. Okay? So when you're looking at your land navigation and you look at your maps and you're looking at a patrol route, these are some things you want to consider. Are they even passable? Now, most things in this part of the country are passable. Now, they may not be the easiest thing, but you can get there. I would advise staying away from the easiest routes because those people are lazy, and that's most where you'd be more apt to be spotted. Okay, so we've covered our scale, we've covered our contour lines, we've got our roads, we've got our waters, we've got the river, and then we've got our creeks. We've got relatively large bodies of water. Here's a lake. And again, that's kind of a euphemism. I'd call it a big pond, but be that as it may. Let's see. I'm trying to see. Okay, now they're going to mark Concord Cemetery right here. And this is Patterson Cemetery, which is still there. And those are some plots you'll be able to find. Now, some of your older cemeteries, like I've got one just east of the house or southeast of the house. And it's probably on here. I'll be honest, I've never even looked for it. Well, actually it is. But now you got to walk back there and it's kind of grown up. Dash lines are going to be more of your logging roads. And there I went with the magnet again. Your colored dash lines are going to be blacktop. Your solid lines that are not dashed are going to be more your county roads. They're blacktop, they're all weather. But, this is County Road 100. And your churches are marked, so you'll have structures there. Now, your maps oftentimes will have a date, the last time they were updated. And I don't see it on here. Now, I got this from Topo USA, which you can go online and rather than buying a true USGS topographic map, you can kind of customize it to your area. Plus, you can customize the scale. Now, this has got a little bit of 3D shading in it, which I thought it would be good. I'm not too fired up about it. The next thing is UTM, Universal Transverse Meridian. It's an easier method to do land navigation than latitude, longitude. And so I got them to put it on here. So these blue lines, this grid pattern, this blue, is what's called your UTM. And down here you have your numbers that correspond. And each square is 1 kilometer squared. So this is a kilometer, this is a kilometer. And then you can figure out your coordinates based off that. And that's something we'll go over in a future time. You'll always read east to north. And then the greater number of digits you put in there, like this is 428, this is 429. So 428, 550 would be right here. This would be 429.00. If it was right here, it'd be 48.25. You get the idea. Same thing going north. So if we were doing this grid right here, it would be 428, 37, 3712. I mean, no, it'd be 172 because it'd be the same number. It would be 6 digits. And that would be the coordinates of this spot right here. And last but not least, magnetic declination. And I'm going to do a separate video on it by itself. What I would recommend, if it was me, if you don't have a compass, get either a Sunto or a Silva. The reason being, I don't know if you can see this right here, but on the back, you've got this little screw and you've got this black marker and you've got a grid and it's got east declination, west declination. Now, on this map, it was updated in 2009. There were 2 degrees difference from magnetic north to grid north and true north. Okay, and this is we'll go over as well. So, grid north is this right here. Now, right here, you're going to have an arrow. You're going to have one arrow STN at the top of it with a star. That is true north. That will line you up with the North Star. That will line you up with Polaris in the nighttime sky. You've got another line. Sometimes they have a little arrowhead. This one doesn't have an arrowhead. It says MN. That is magnetic north. Magnetic north and true north are not the same thing. The actual North Pole that this thing points to, the magnetic North Pole, is somewhere in the Hudson Bay, and they don't line up. The wonderful thing of living in the great state of Alabama in this area, there's only 2 degrees difference. Not a huge issue. If you're in Washington State, it's a huge issue. Now, you can take the Lensatic compass that the military issues, and they're great compasses. They're heavier than this. They give you mills. I'm not adjusting artillery fire, so I'm not too worried about mills. But there's no way to set declination. So every time that you shoot an azimuth with this, you have to convert your magnetic azimuth on that compass to the grid azimuth or true azimuth on the map, or vice versa. If I use this as a protractor, okay, and I want to go due east, all right, that's 90 degrees. Well, if I've got 10 degrees magnetic declination, and let's say grid to mag you add, mag to grid you subtract. So, and I'm not even going to get into that. That's a separate video by itself. Just remember that there is magnetic declination. But if you're going to be in this part of Alabama, now this moves, because in 2009, it was 2 degrees. I looked it up today, it's 3 degrees. Trust me, if you buck and brush, you ain't going to be within 3 degrees anyway, so don't sweat it. But if you are somewhere where there is a variation, you got to keep that in mind. And it's a whole lot simpler. You'll get less apt to screw up, under stress especially. If you can go ahead, look at your map. All right, this is where we're going to be. I'm going to set my declination on my compass. Then my grid azimuth and my compass azimuth, say that 3 times real fast, will match. Okay? All right. So, that's got us, I got to figure where my time is on here. Well, I thought it'd give me my time. It gives me the time of day. Anyway, we're going to stop right there. And we're going now to start putting this to use. It's not near as complicated as it sounds, okay? But it's something, the more you do it, it's no different than you going down the road and you're reading a road atlas. Now, I know everybody's got GPS. I'm not against GPS. GPS is a wonderful thing when it works. When it don't work, you're SOL. So, with Mr. Murphy writing his law, being an optimist, able to use a map and a compass, have a map of your area, and have a compass, know how to use it. Now, we'll discuss also terrain association, and we'll do that in a separate video as well. But what we'll do now is I'm going to stop this video. We're going to start part 2. In part 2, we'll start talking terrain features, contour lines, that sort of thing. Then we'll start setting up. I'll draw kind of a make-believe map, and we're going to plan a route. Okay? All right. Well, I hope this was beneficial. I hope I didn't confuse you. Like I say, it's not near as bad, and the more you play with it, the easier it gets. And you can do this on the kitchen table. You know, and then take it out and use it. Okay? comments, questions, criticism, witticism, let me know. And I'll be back in just a second. Thank you very much.